Alrighty, in this video we're going to start putting our server API together. So basically what that's going to be is a collection of classes that we are going to use on the server side to provide functionality for the system. There's a handful of things that we will need to put together before we can start making our own systems and seeing some communication. One of the first things that we need to do is we need to write some sort of abstraction over the Photon peer. So for people unfamiliar with Photon terminology, the peer is a class that's responsible for handling the communications directly with the client. And it does things like receives operation requests from the client, and it also allows us to send information to the client. However, I don't want to reference the peer directly throughout the majority of this code. Although the system is being built directly with Photon in mind, and I'm not trying to abstract everything from Photon away from it, I do feel like it would be nice to have a abstraction over the concept of a peer, just to make sure we know exactly what it is we are tying into as far as Photon goes. In addition, I also want to put together a object that will encapsulate all the information about an event that can be sent to the client. Now, the reason that's important is so that when we send an event to multiple clients at once, we don't have to reconstruct that object every time. Now, you might be asking if I'm going to be doing batch serialization. What I mean by that is serializing the event once and preventing it from being serialized over and over again by by Photon itself. Now, remember, the serialization that we do using the simple serializer will be cached. Unfortunately, in order to do that sort of serialization with Photon, you have to have knowledge of what protocol type that each peer is using, and it's something that I want to address later because I kind of want to see the system all in place first before I write a mechanism for doing any sort of batch serialization with different peers. I'm sure there's an easy way to do this, but for now, I'm just going to just write the event class as the abstraction and leave it at that. So basically, the first thing that we need, of course, is going to be the concept of an event, because obviously, for example, if the server decides to create a new system on the client, or the server wants to say something like, here's the component map and all that fun stuff, we need to send information. And so I want to put the event class together. Probably won't be building any specific events quite yet. Maybe we will when we get into building the client systems class, and then also write the basic interface that's going to wrap a peer. Now, there's kind of actually different levels of wrapping a peer, and it really depends on the way you look at how these objects are represented. We're going to have an object or a class called a client context, and that client context class is going to be our representation of a single connection. And then the client context class is going to be made up of things like a collection of systems that have been enabled on that particular client, as well as its transport method. And the transport, as far as terminology goes, that's what I'm referring to basically as the abstraction over the peer. We'll have what's called an iServer transport interface. And then in addition to that, the contexts themselves, the client context, we're going to have a variety of subclasses. We'll be starting off with just a player context. And the reason that's important is because different connections might have different things that need to be done on them. Like, for example, we might have a server-to-server connection, or we might have a dashboard connection or something like that. And I want a place to put some context-specific things into. So, for example, our player context will carry information such as the current character they're logged in, what zone they're in, and all that fun stuff. Obviously, that's information that's going to be irrelevant if a dashboard application signs into the application, or there's a connection between a master server and a region server. So I do want to bear that in mind. In addition, we will be using a autofac, at least for now, to instantiate our systems. So that'll be handled in with a dependency injection container, which will be really nice, so that we can do fun stuff. And of course, we'll also have a server context. And the server context class is going to be essentially our representation of the application. It'll contain things like the AutoFact container, the system type registry, and our component maps. So yeah, it won't be very easy writing these classes on video, unfortunately, and that's because they are all very intertwined in that it's a very, very tight object graph that we're putting together here, and these classes themselves aren't particularly difficult or complicated, but there's going to be a handful of them, and they do kind of work together, so that's going to be a bit of a challenge. I guess the first thing I want to go ahead and get written is in my base project. I want to go ahead and open up my infrastructure namespace, and I want to create a handful of enumerations. And these enumerations, although we're not going to be filling any of them in quite yet, are important so that we can make sure our code continues to compile. And these are the enumerations that are going to represent the different parameter and event and operation codes that we can have. So we're going to need 4 of these enums to represent the different things that we can do at the low level of the system. So I'll go ahead and start and create one. Let's call this operation code. And then, of course, for operation code, I'm going to make sure the backing type is a byte, since our operation code is going to be serialized as a byte anyway. Might as well instruct the runtime to allocate only 1 byte of information per operation code. Next up, we're going to have our operation parameter, which will also be a byte. And again, these enums are empty for now, but I'm just putting them in there because we will be statically referencing them occasionally from within our code. Then I'm going to go ahead and build 2 more enums. We're going to have event code, which of course will have a backing type of a byte, and it'll be empty. And then an event code parameter type, which will have a backing type of a byte. So again, we use these just to represent different, like what sort of operation is happening on the client or what sort of operation is going to happen on the server. We use these to tell them what's up. And again, they're very low level enums. We won't be adding operation codes, for example, for things like sending a chat message and doing all that fun stuff. The reason we won't is because that's all handled with our systems API and not through the low-level Photon API. So these are all low-level enums. And of course, they have to exist on our base project because it's going to be shared by both the client and the server. Okay, so if we go ahead and jump into the server, I'm going to start off, again, everything is really intertwined. So I think I'm going to start off with the event class. So I'm going to create a new class, and I'm just going to name it event. And again, the event class is used to contain contained a sendable event so that we can send it to multiple peers without recreating the objects. The way I'm going to write this event class is going to be very kind of interesting. I'm going to have a public iEventData parameter with a public getter and a private setter. Then I'm going to have a public send parameters with a public getter and private setter. And these are really the 2 pieces of information that Photon will need in order to send an event. You might be asking where the dictionary is if you're familiar with Photon. And what I'm going to do is I am going to go ahead and write a helper method on the event class to construct an event instance that is created from a dictionary. So I'm going to say protected, or let's just make it public static event from dictionary, and it's going to take in a event code. Of course, this will bring in a using statement for base infrastructure. I'm going to name this parameter code. It's also going to take in a dictionary, which comes from collections generic, and the dictionary will have a key value of byte and a value type of object. We'll call that data. And then it'll also take in a send parameters. And what the from dictionary method is going to do is we're simply going to say return new event, and we're going to use object initialization syntax here and say event data. Now this is very important. We're going to say event data equals new event data. Now notice that I'm instantiating an event data class. I'm not instantiating an iEventData interface because, well, you can't instantiate interfaces by definition. So this event data is what you would commonly be using with Photon when sending events. Again, this event class is nothing special, it's just a container and something that we can easily change later down the road if we want to change how our system interacts with Photon, or we want to swap it out with a different transport layer. For the arguments passed into the constructor, I'm simply going to say cast to byte code followed by parameters, or send parameters. And then I'm going to say comma send parameters equals send parameters. So we get all of that information there added to the event class. So the way I intend to use the event class is I'm going to make subclasses. In fact, I think probably a more appropriate place to put this class would be in an events namespace. So I'm actually going to go ahead and create a new namespace inside the server project. I'm going to call it events. Actually, I'll leave this class outside of that because the event-based class is kind of, or the event class is kind of an infrastructure concern. And when we go and actually start making our own events, I'm going to make one class per event. Now, what'll be interesting about these classes is they'll just have a public static method that invokes the from dictionary method that we see here. The reason I want to split it out into different classes, each event into its own class, just so that things are a little bit more organized and we have a little bit more fine tuning or fine control over the way that we construct our dictionaries. Now that I have that class, we can go ahead and build up our transport. And again, our transport interface is just the abstraction we're going to have over up here. So I'm going to generate a new interface, and I'm going to call it iServerTransport. And inside iServerTransport, it's going to have two methods, because there's primarily two things we can do with a connection. We can send data, or we can terminate the connection. So I'm going to say void send data event, and then I'm going to say @event. And you'll see me use this a lot when working with variables of type event. The @ symbol is the literal symbol in C#. It allows us to use language keywords as identifiers. Note that if I did not have that @ symbol there, event would be considered a keyword, and unfortunately C# is not going to well, it's going to throw a syntax error because the keyword right there isn't allowed. Unfortunately, the event keyword is not a contextual keyword. In later versions of C#, as they added more and more keywords, they made these contextual keywords, which are really cool because they're only keywords in certain contexts. Unfortunately, event is always a keyword, meaning that even when it doesn't make any sense for it to be used as a keyword, it requires us to effectively escape it using the @ symbol. Then I'm going to say void disconnect. So these are really the two things that matter to us at a higher level about a connection, being able to send data to it and being able to terminate its connection. So the iServerTransport is very interesting, or very important rather. Now we can start thinking about we can't write our client context class yet because our client context class, like I said, is kind of a collection of all the components that we're going to work with when using this API. So you can think of it kind of like the entry point into the concept of a player or another server and so on. And that class is going to depend or require things like a bag of systems. So we've been talking about the system API for a while now. Most of the stuff that we've been doing is all about building up these systems and supporting the RPC framework through them. So now what we can do is we can go ahead and put together a client systems class that you can think of it like just a bag of systems. So when we want to, for example, have a select character screen show up, we could add a character select screen to the systems collection. So our system collection is kind of what that is. So the systems is going to be a bit interesting. Let's go ahead and get that class started. I'm going to add a new class and I'm going to say client systems, and then inside of here, we're going to need a constructor. And so what's interesting about this is we are going to need a reference. So unfortunately, this is going to be a bit, we have sort of a circular dependency going on here between our client systems and our client context, because our client systems is very, very coupled to our client context. In fact, the whole responsibility of this class could lie entirely within the client context. It wouldn't make much of an architectural difference, though it's a little bit cleaner doing it in two classes. But unfortunately it requires a sort of circular reference. The reason why it requires a circular reference is this class is going to be responsible for instantiating systems. Now systems are going to need a reference back to their original client. You know, how else would those systems do things like move on to the next screen or affect a player's avatar or whatever. In addition, when those systems are instantiated, they're also going to need a reference to the server context so that they can provide sort of global things. And also our server context, since that's the thing that contains our component maps and our type registries, we need to have a reference to that as well. So let's go ahead and do that. I'm going to take in two parameters. It's going to be a client context, and I'm just going to call it client, and then a server context, which I'm going to call server. Or let's say server context, and let's call this application. And then I'm going to go ahead and have both of these added to local or assigned to local read-only fields. And so you notice that neither of those classes have been created yet. So we might want to go ahead and do that. Before we do, though, I do want to go ahead and write out the public interface for client systems. And what I mean by that is the public methods that are going to be invoked to do things like create a system, destroy a system, and so on. And we'll also need a way to retrieve systems so that the peer object can invoke methods on them once they receive that message. So the first thing is we need a way to create a system. Let's think about how the API for that would look. I'm really thinking it should just be public t concrete type create concrete type. I think that's not how you spell concrete. I think that's going to be a really nice method to invoke when we want to add a new system. For example, I'm just going to throw down some pseudocode down here. Like, for example, to add a new system to the client, we would do something like client.systems.create login system, for example. So that's how the usage of that method would appear to the caller, and I kind of like that. And then in addition, we're also going to say public void destroy t concrete type. Now you notice I'm calling these generic parameters that are inevitably going to be replaced with the actual system we want to create or destroy. I'm calling it t concrete type. And that's a bit of a terminology I talked about in the last video, where the concrete type is going to be the thing like the login system or the chat system or whatever, as opposed to the interface types, which would be the interfaces that exist in the base project. So to keep that terminology, just to point out to whoever's going to read this code, what we're expecting is the concrete type when we create a system, not one of the respective interface types. So, all right, so we have the public API for that. Let's go ahead and do a public t concrete type get. This allows us to retrieve a system from within our client systems. So it's very important to enable cross-system communication because, you know, the avatar or the current thing in the game world is going to be represented by a system or contained within a system. So if one system wanted to modify or retrieve information about an avatar, it would have to go and get a reference to another system. So that's why we want to make sure we can get systems. So we have create, destroy, and get. There's also one other one that I want to write, and that's going to be the public. Now this is where things get a little interesting, because what I want to write is a non-generic method. And this method is going to be invoked when we want to retrieve a system by ID so that we can invoke things on it. So remember our component map, how we can invoke methods on objects that are mapped? Well, we need a way to retrieve that based off an ID, and we can make that a linear time search by simply having an array of systems. And so the question would be, what do we return here? A good choice, what all systems, whether they're on the client or the server, are going to implement is the iSystem base. So I'm going to say public iSystem base, which I'm getting out of the Buzz MMO base infrastructure namespace. I'm going to say get by server interface ID, by server interface ID. And so this will be a very quick method that'll return an instance of a system so that we can invoke a method on it. Remember, this will happen when the client tells the server to do something. So if the client tells the server to log in, it's going to need to retrieve the login system. If the client tells the server to move its character, it's going to need to retrieve the movement system, and so on. And so as far as public interfaces go, this really this surface that we're looking at really exposes all the behavior that we really want: create, destroy, and then get by server interface ID. There's not a whole lot other things that we need to do here. So what I'm going to do here is I do want to make sure this code compiles once we get all the stubs for all of our classes figured out. So I'm going to have these just throw new not implemented exceptions. And you'll notice a reference to using system, or reference to the system namespace appear at top. And this also will remind us to implement these. And again, I do this because, for example, this method won't compile unless it's returning a value. A way to get around that is to throw an exception in the code path. So we can take advantage of that little bit of the C# specification to prevent us from having to actually write these methods out before we get the rest of the scaffolding working. So that is our client systems. Now we definitely need our client context and our server context, which will act as kind of containers for the client systems. However, we'll need a NuGet package for this, and that'll be autofac, because like I said, I want autofac to be responsible for instantiating client systems so that we can have them accept dependencies throughout the rest of the system, so we can register services and have our systems depend on those services and keep our code really clean. Another benefit of using autofac is each client is going to have its own lifetime scope, meaning we can have services that or systems that request services, and then those services be only instantiated on a per client basis, which is a really important feature. So I'm going to come up here to references on my server project and say manage NuGet packages. And then on NuGet.org, I'm going to search for autofac. I'm going to install it. So then on the server project, I'm going to create a new class, and I'm going to call this server context. And so the server context is going to need, think of it like the root of the application. It's going to need a variety of bits in it. For example, we're going to need a component map, two component maps, the system type registry, and an autofac container. So I'm going to say public component map, which will bring in base infrastructure. And I'm going to call this systems component map with a public getter and a private setter. I'll say public component map, and we'll call the next one actors component map. Remember, we're using two component maps so that we have a wider range of component IDs, because each component ID can only go up to 255. Since actors and systems are completely different concepts, they'll never need to mix. So we can reuse a lot of ID numbers and effectively double the amount of interfaces the RPC system supports by using 2. Then I'm going to say public system type registry, and I'm going to call this system type registry, since we're only going to need one instance of the type registry per server. Then finally, I'm going to say public iContainer. I'm going to call this container, get private set. Now, some of you guys might be, who are maybe more familiar with IOC, might be asking why I'm not making the container property internal. I could certainly do that. I can certainly hide the container from the rest of the application to prevent any sort of accidental dependencies on a service locator, which the service locator pattern isn't a very good one. It's typically considered to be an anti-pattern. But I kind of don't want to lose that flexibility. There are times where we will or might need to reference the container directly, although I do want to discourage referencing the container directly in all cases except for inside of this assembly. I'm not going to worry about putting together, well, actually, no, I'll do even better here. I'll go ahead and generate a constructor, but I'm going to have it throw a new not implemented exception, which of course will bring in system at the top. That's again just going to remind us that we need to implement this before we start, actually building anything. Okay, so now that we have the server context done, let's work on our client context. So I'm going to come up here to the BuzzMMO server. I'm going to create a new class. I'm going to call this client context. Now, I don't know if I want to make this class abstract or not, because I want to override this class for every type of client that can connect, be it another server, a dashboard system, and some sort of admin panel, or a player. I guess I can go ahead and just make it abstract, just to prevent the accidental instantiation of a client context directly. And then what I'm going to do up here is actually, I think what would be really... I think I can go ahead and have this reference a server context, and we'll call this application. He's also going to have client systems. We're going to call this systems. And I'll have a public iLifetime scope, which comes from AutoFac. And we'll call this client scope. And then we're going to have a public iTransport, or iServer transport, and we'll call this transport. For his constructor, I'll go ahead and throw a new not implemented exception, brought in system at the top. Now we have to talk about what sort of methods the client context is going to have in it. Primarily the client context is just a bag of state. It's a bag of, it's kind of the root object. It'll have things like all its systems and reference the application and the reference the client scope and all that fun stuff. What I can go ahead and do is, let's go ahead and just write the other methods. I do want to make sure the client scope is disposable, so I'm going to have it implement iDisposable, which will require I add the public void dispose at the bottom, and I'll simply have this throw a new not implemented exception. And I typically like the dispose method to be the last method in the class, so I'll write all the other methods above this. As far as methods go, the client context itself is going to be responsible for actually performing the operations themselves, and that's so that the photon peer is relatively anemic. We don't want to... I don't really feel comfortable writing a whole lot of important logic into the peer because it has so many different responsibilities. So instead what I'm going to do is I'm going to have the onOperationRequest method, the method that actually gets invoked when the client tells the server to do something. I'm going to have that live in the client context. This also gives us the added benefit of changing what operations do what on a per client type basis. So we can have different operations for a player versus a dashboard, for example. So what I'm going to do here is I'm going to say public, and I'm going to make this virtual. I'm going to say void on operation request, which is going to take in an operation code. Of course, that comes from base infrastructure. And it's going to take in a dictionary, which comes from collections generic of byte and object, and we're going to call these parameters. Sadly, we won't be able to accept a dictionary of operation parameter, because that would be really cool, but we won't be able to do that. The reason is because the type system just simply won't allow for a direct conversion between the dictionary of a byte key and a dictionary of an operation parameter key, which means that the only way to have that work is if we do the conversion ourselves in code. Honestly, that's just a big waste of time. I don't want to instantiate and copy a new dictionary on every single request just so I have a slightly easier time accessing the parameters. After all, this is all relatively low-level frameworky code, so I can take some liberties with performance, or not take, you know what I'm saying. Take liberties with the design. I'm going to have this throw a new not implemented exception. Then I do want to go ahead and write an interesting method that might not seem entirely obvious to people as to why I need it. And it's going to be protected void invoke method on system. And what this is going to do is it's going to take in a byte server interface component ID, and it's going to take in an object, or it's going to take in a dictionary of byte and object parameters. So why am I writing this method? Well, if you recall, I want all the client telling the server what to do. I want that all those requests to go through this on operation request method, right? Well, what is going to happen 99% of the time? It's going to invoke a method on the system. And no matter if you have a dashboard connection or a client connection or player connection or an admin panel connection, whatever, invoking a method on a particular system is going to be, well, the same thing every time. So if the on operation request is overloaded by a custom class, and then it decides it wants to invoke a method on a system, I don't want to force it to rewrite all that code. So instead what I'm going to do is I'm going to have the invoke method on system be a separate method that will be usable elsewhere. Alright, so really that's about it. I'll throw in one more method at the bottom here, or right before dispose, and it's going to be an internal void on disconnect. So why am I writing an on disconnect method here? Well, I definitely want the client context to be notified when it's disconnected, but I want the on disconnect method to be invoked from the peer. So the peer is going to need to invoke the on disconnect method, because when we invoke dispose on the client context, we're going to tell the peer to disconnect. When the peer disconnects, we want to invoke some sort of handler logic for disposing our other components. And so we need another method that gets invoked when the peer disconnects, because otherwise we'll have a we'll have a recursive method invocation. Okay, so if somebody invokes dispose on the client context, this method is going to tell the transport to be disposed. Transport is the peer. Then once the peer is disconnected, the peer will be notified of it being disconnected, and it's going to have to notify the client context that it was disconnected. So it'll invoke the onDisconnect method. So that's why we need it there. That's why we're not putting our dispose logic in the dispose method. The dispose method is simply going to tell the transport to disconnect. Then once the transport is disconnected, then our dispose logic will be invoked. Okay, so that's all that fun stuff. we are going to need some other things. Let's go ahead and just step out a few more methods that I know, or classes that I know we're going to need at some point. So in this project, I'm going to create a new class and I'm going to create a player context. That's not even close to how to spell there we go. The player context will inherit from client context, right? So we have player context inherits from client context. We're going to leave it blank. Again, this is where you would put player-specific logic in. Things like aliasing out his avatar, for example, and stuff would go into this. Let's see, what else do we need? We're going to need an interesting interface, and we're also going to need a peer. Well, actually, let's think. Yeah, I'm not going to worry about. Now, let's just go ahead and do that. So we need a peer. We're going to need a special internal interface for our systems. We're also going to need the base class for our systems. So let's go ahead and get these done, just at least out of the way, so that we can focus in later videos actually writing these methods up. So on the server, I'm going to create a new interface. I'm going to do a weird little interface first. It's going to be internal system. And I'm going to change its accessibility from public to internal, like its name suggests. And it's going to have one method on it. It's going to have void init client context client object proxy. So what is this? Well, as you'll see in a moment, or when we write our systems, we need to be able to instantiate the systems, but then we need to tell the systems about the client context, and we also need to tell them about the client proxy. But I don't want to expose that method publicly, because if I exposed it publicly, it would be accessible from within other code outside of this assembly. So I want to kind of hide the init method into this interface. So we'll go ahead and get that interface written. Let's go ahead and stub out a peer real fast. I'm going to call this MMO peer. I'm also going to add MMO to my abbreviation list. And he's going to inherit from peer base. Inheriting from peer base will require that I implement one or both of these constructors. I'm going to go ahead and implement this constructor right here that has the init request. And of course, I'm going to throw a new not implemented exception in it. Then I'm also going to implement the two required abstract methods, the on operation request and the on disconnect. So they're just going to kind of sit there. So that's our MMO peer. Last thing we need to write is our actual system class. And this is going to be kind of interesting, actually. Let's think here. Okay, I'm going to write two base system classes. So let's go ahead and write the first one. I'm going to create a new class, and I'm going to call this client, or what am I going to call this? I'm going to call this client system base, and I'm going to say tick2 because it will have two generic parameters. And it's going to have a T server interface, T client interface, and it's going to inherit from, actually we can do even better than this. Before we do T server interface and T client interface, I'm going to say T context type. This will make sense here in a moment. Now, what is this class going to implement? Well, first it needs to implement iSystem base from the base infrastructure namespace, and I'm going to supply T server interface and T client interface as the parameters. It's also going to implement our iInternal system interface. So iInternal system. Then I'll go ahead and have it implement all three of the required things. These guys come from the iSystem base. This guy comes from the internal system. I'll go ahead and just implement these two properties since they're so easy. The server system interface simply returns type of T server interface, and this returns type of T client interface. So what's this context type? Well, our systems are going to need a reference to A, the proxy object that represents the client, and B, the client context itself. So that's how systems interact with each other or deactivate themselves or whatever. So what I'm going to do is I'm going to say protected T context type context. And so this might be a player context, it might be a client context, whatever. Then I'm also going to write a protected T client interface, and I'm going to call this proxy. So we have context and proxy. However, for my player systems, I don't want to constantly provide this third generic parameter. So I'm going to use a really simple trick to create another generic type. Also, I want to go ahead and change the name of this from tick2 to tick3, since we have 3 generic parameters. So I'm going to go to, well, I am also going to make sure we add a generic type constraint here. So all the way at the end of this, you see the public class client system base, all the way at the end here, I'm going to add a new line. I'm going to say where T context type inherits from client context. So this will ensure that whatever parameter we supply or argument we supply for that generic parameter, it'll be a client context. Now that we've done that, let's go ahead and write a convenience class, and this is just going to be called player system base tick2. He's going to have 2 generic parameters, which is going to be the what is going on here? I don't know what's going on here. T server interface, T client interface, and he's simply going to inherit from client system base, and he's going to supply the first generic parameter, which is going to be player context. Then he's going to supply the other 2 with what was passed in by the inheriting class. So this way we have a convenience thing that we can use to just inherit from instead of supplying the player context all the time. So player systems will inherit from this, and they'll receive a player context, whereas you might have a system that's specific to a dashboard that would receive a dashboard context, or you might have a system that's specific to another type or another server, and you would have another type of context. The last thing I want to do here is on my server context. I want to go ahead and introduce the possibility of having more component maps than just the systems component map. And what I'm thinking is other systems like a dashboard system or a separate server system and all that fun stuff, we could use their own component maps so that we don't waste space telling the player that you have these other components available if those other components are only used to facilitate server-to-server communication or admin panel to server communication. So instead of systems component map, I'm going to call this player systems component map. And what we can do is I can have that component map be supplied by the constructor of our client context, and then it'll have that information. But anyway, so here's these classes here is just the basic stub for the entire server API, just for the systems. Again, I'm wanting to get systems working before we work on actors because systems are inherently easier to work with, and we'll be able to see some client-server communication. But I think that really wraps up the stub. So I guess in the next video we'll start taking a look at implementation.